Hi guys, welcome back to my series Blender for Production. My name is Helge from pixeltrain. It has been a while that I published a tutorial. I was really busy in working at my own projects and also teaching. And now I come back with a new tutorial for this series because I found in my teaching for professional studios that we have now a software combination which is really interesting. More and more studios are adapting Blender to their pipeline or thinking about that, and they want to connect now Blender to their existing pipeline. And on the compositing side, nearly all my clients use NUKE. And so one of the things I'm really often asked is how to connect these two worlds. So I want to show in these tutorials some gotchas which you fall into if you are rendering directly from Blender to NUKE. And I want to show you some easy solutions. So in a professional pipeline, most of the tools will then be scripted. And I also understand that many indies out there are not wanting to script their solutions. So I want to show you ways how to manage the communication between Blender and NUKE. And you also can adapt this know-how then maybe also for other compositing solutions like Adobe After Effects or Fusion Studio. So it's not for the lazy people. I will explain a lot. I hope you find this useful. If yes, please subscribe, give me a thumbs up, and let's get started. I've prepared a really easy scene here, and the background for this scene here is that I wanted to show you nearly every light path we can generate inside of Blender so that we can then analyze the output inside of NUKE. So we have here dielectric, we have here conductors and metal, we have glass here, we have emission objects, also subsurface scattering here, and a volume, so nothing too artistic here. And what I now want to do is I want to show you the straight way of delivering an image first to NUKE, and then we want to analyze what's going on. The normal way people go into Blender and try to save out their rendering is that they find here these output properties, and here's an output area, and then they set here the path and they select yes here OpenEXR multilayer so that they can have more than one layer in this EXR, and then they press render and yeah, it doesn't work. The reason for this is that this output path here is only for animations. So if you don't render animations, only still this here isn't used at all. So this is the first thing. How to do that? If you are rendering, let's do that really fast. And for this, I bring down my resolution here to 25%. So it's much faster now. And I also go here into the sampling and lower my sampling here for a test. Let's do 32 samples here in the rendering. And then we go here to render image, or you can press F12. And now it's rendering. And normally you see a pop-up coming up with an image editor. I've switched that off because I find this really annoying, and this is a good point to understand now where your rendering lives. So if you're rendering something inside of Blender, you normally have the render result inside of an image viewer. If you don't have an image viewer, you can't see it. How to prevent the image viewer from popping up? For this, I go to the Blender preference by Command comma, or you go here to edit preferences, same way. And here under interface, there's a temporary editors section. And here you can tell where the rendering should be. Normally, this is new window, and you can also say always send it to the open image editor. Or if you have your own layouts and you don't want to have somewhere an image editor suddenly in a panel which you have pre-selected, you can tell the system, okay, keep my user interface, don't change anything. And that's exactly the setting I had. So where's my image now? Two ways of getting it. One would be render, and then here view render. So this would open the image editor, but I don't allow that. So I can go now here, open a new panel. In the header of my panel, I can go here and open an image editor. And if you don't see your render, you can open up here the list of all images which are in memory for Blender. And here's always a render result. And render result is your last image. So this was rendering an image into an image editor. If you now want to save this still, you go here to image, and here is a save as. you go into your Blender file save dialog, and for this tutorial I made a tutorial Blender and NUKE. Here is a render subfolder. If you don't see something on the right side, press the N key on your keyboard for the N menu, or here this little cogwheel. And then you can select here multi-layer EXR, set your settings, and you see here under color depth we can half float and have a full float, so both are possible. And then you can save this EXR out. So that's the first step, how to get a still over. Like I've said, if you render an animation, you don't need to do that, so Blender saves directly. But to do that right, you have to go here into your output properties, and if you now want to save somewhere, you can select directly the path, or there's a really convenient thing here. If you make a double slash, Blender searches always for the saved blend file. So this is the position of your saved blend file, double slash. And then I use my subfolder render, and if this subfolder, which you type in here, doesn't exist, Blender automatically generates this subfolder for you. So, and then we can say this is our animation. And now you have to make sure that you use these pound signs here as placeholders for your frame numbering. Otherwise, you get an overwritten file, because here image sequence override is on, so Blender's allowed to overwrite your file over and over again, and after some hours of waiting you only have one file left. So use these pound signs for telling Blender what file numbering system you want to use. Then I type EXR here as my file extension, and then you go here and tell the system open EXR, set your settings like before. If you want to have a JPEG in the folder beside of the EXR, you can tick that here, and then you have to render your animation. So set your frame range here, and instead of going to F12 or render image, you go here to render animation. That's all, and then you get your sequence. To see then the sequence beside of view render here, you also have view animation here. So that's it for animations. But in most cases, if you now want to go to NUKE, you need passes. In some render engines, it's named AOVs. In other, you maybe hear the word pass. Render element is also a word. It's all the same. In Blender, you find these settings here in this section, View Layer Properties. So these are all the passes, and if you now take a look here, I close them down here, you see there's a bunch of light passes which you use for composite your beauty back. So these are the light passes. Then we have data passes here which you use for relighting purposes, depth of field in the post, and many more things. And you also have the ability to generate cryptomats for your work. So this is the normal work here of adding passes. What I will do now for this tutorial, I will give you everything. I want to show you the gotchas, so I do something like that here, which I don't normally do. I normally select exactly what I want to do. Yeah, but this is a tutorial, so we want to see everything. Also, we want to have all the cryptomat ideas here. And a little side note for the pros. You also can have shader AOVs, so you can add here your own AOVs from the shader, but I think that's a topic for another tutorial we then do. Now we have to re-render. Let's do that. This time I have an image editor open here, and render result is on top, so let's do the same thing again to have a fast render here. Okay, looks really ugly, but it's fast, that's nice. And if you are now in the image editor here, you now see something new here. You see here we have a drop down, and here you see the word composite. If you click here, we have composite and view layer, and the question is, what is view layer? Blender has a render layer system, and if you want to know more about that, I made in my Blender for Production series a whole series about the Blender Compositor, and in these I explained also what render layers are. So if you want to learn more about render layers inside of Blender, please refer to these videos. But in short, we are on a render layer with the name view layer, you see it here, and this is the name of my render layer. So that's the thing here. All our settings which we made here, these passes here, are part of this render layer. You see view layer. It's the same name. So every render layer inside of Blender can have its own passes. So that's the connection here. And if you now click here and say, show me the view layer, you get another drop down here. Now we are on the view layer or on the render layer with the name view layer. And then we have here all the list of the passes which we generated. You can now look through them and see them in all its glory. And combined is the beauty pass here. If you now save your image out, again, you see again the same settings like before. And if you have made sure that you have OpenEXR multi-layer, you get exactly what you expect, all the passes. And this is something I now want to do to show you some problems with that. So I say do that. I name it low res, only that you believe me that I know that it's really low resolution for now. So let's save that and switch over to Nuke. Here we are. And I press my R key for read node. And I now read in my low-res EXR. Okay, here it is. First thing people are complaining now is, look at that, we see something blackish here. So you don't see data in RGBA, which you normally expect. So it seems nothing is here, but you see here now all the layers. And if you take now a layer context sheet, for example, it's the fastest way to see everything. And I show the layer names here. Let's press the space bar to look into that. You see everything is there. The reason why you don't see it is that the beauty pass, which you normally see under RGBA, is named composite underscore combined here. And there's another beauty pass here, view underscore layer underscore combined. And you have read the word view layer before. So this was the name of our render layer. So Blender has the tendency to always add the name of the render layer to the layer inside of the multi-channel EXR. And if you now as a 3D artist rename your render layer, which I do normally, you will break maybe your Nuke script on the other side. So this is something I don't want. So we need predictable names later. Also, you see it doesn't take the name really serious because now we have an underscore. In Blender, we had a space. So also two different things here. What you now can do is if you remove the contact layer sheet here, we can go here and say, okay, I know now how Blender thinks here. I take now, for example, the Compositor and then we see our beauty. But yeah, this makes a big problem in production. You see that. If, like I've said, someone now renames layers or you have more than one render layer, then you have a whole bunch of maybe empty layers here. The names are not fitting, many problems. Another thing, we also outputted cryptomats here. So if I now take the cryptomat node here, for example, you will also see, yeah, it takes it here. It seems to work somehow. Let's test that really fast. We go here to cryptomat object. I go here to my picker and I pick here something. You see there is something going on here. Let's go to RGBA. Yeah. And then say mat only. Yeah, it seems to work, but yeah, this name is a problem. In some versions I found that also the cryptomat layers are not found, so really big problem also on this point. What I want to show you now is a really easy way of working with that without hassle and to predict which layer you get inside of your Nuke script. So let's switch over to Blender again. And for doing that, I use the Compositing interface and a side note for that. Blender is meant as a full studio solution. The normal way a Blender user would work, so I reference back to my Blender for Production compositing tutorials, is that you can render directly from the render process here into the node-based compositor here. And inside of the node-based compositor, if you tick here use nodes, you get a render layers node. You can add them by yourself because here you can select now our render layer, which we want to work on. At the moment view layer, that's the same like here. So here's the name again. And then we can start compositing here in this environment. At the end, you directly output everything which goes here to the composite node. If you press render, Blender will render first, delivers the data here. Here you have, for example, in a lower resolution, that's the reason why I lowered here my percentage. You go to your composite tree, test everything, and if you later render in your final resolution the whole animation, this tree runs directly, and the file which is saved out through this composite node here is then the final file. So that's the idea how Blender works, and it also goes a step farther. If you go here to the post-processing, it sends then the file to the sequencer, the video editor inside of Blender, and you can have it directly in your edit. In studio production, we normally want to bring the files then out because I want to do, for example, something inside of NUKE or Fusion or whatever. So we use now this compositing environment here for delivering the right passes out. And what I do here to control this a little bit better, I split here my window and show here our friend the image editor again. You can see here, if I open now the image list, you see here is the render result which we had. Okay, I made sure that backdrop here is gone because I don't like it behind my node tree. And another thing which you now can see is that we have here a second node which is a viewer. The viewer is a helper for me. You get it if you have activated the node wrangler in your add-ons, and you can then Control-Shift-Click here on a port. And this viewer is now showing that. And you can see the viewer output by showing here the output of the viewer node. You see, here's render result, here's the viewer node. And if you do that, you now see I can analyze every output here. So these are the data which I want to use now in NUKE. How to get now this out? We have learned that if this tick is on here and also use nodes on here, that every pass here is now delivered to the compositor, and normally would output it here. What I now want to do is I want to go into this tree and now grab the data which I want, and I deliver that to a node which has the name file output, which you see on the output. And this node first seems not very useful. You see, you only have a path and one slot, which is an image slot. So if you connect that here, you can save out, for example, your beauty here, which is named image here. Yeah. But this node can be pimped up. Let's do that here. I select the node and I press the N button on my keyboard to open the N menu. And normally it opens something like that. Go to item. You see here now the properties of this node. And here you can open the properties again. And now you see that this node has much more properties than you think. The first thing here is that you have a path. Again, you see I address here with the double slash the path where the blend file is, then I go into the render, and now I go in here and say I want to rename this thing here, and I say I want to name this multipass, and I don't want to render an animation, so I don't think about any pound signs for image sequences. I directly do it like that. Then I select here multi-layer, RGBA, float, full. And now you see that this input here is also in this list here. And now comes the cool thing. You can add as many inputs as you like here. And now you see you have more things here. And if you have as a file format the multipass EXR, you can save now everything which you plug in here. These ports here are neutral. First, you see all of them are yellow. But if I now take, for example, here a normal pass, which is a vector information, and I plug it in here, you will see that now Blender changed the data type here of this pass to vector. And the same for all others here. So that's the first thing you have to understand here. Second thing is, if you select now here one of these ports, and you want now, for example, that the normal pass here, which comes in here, is named normal inside of your EXR, you can rename them here. So you select it here and rename it normal. And this now is exactly the name which is delivered into the EXR and which you get then inside of your NUKE script. So image for the beauty is not the name I want, so I name this RGBA, for example. Yeah, and so I have my RGBA here. And that's it. So if you want to resort something, you have here these up and down arrows. You can also select here something and click here this little tick so to remove it. And you also see later that empty ports here will not be delivered into the EXR. So what I do in my studio production is now that I have decided which kind of passes I want normally and how I want to deliver them to Nuke. So to have a standard naming convention for my Nuke scripts. And if I do it here, before I render the whole stuff out, I don't have problems later in Composite that suddenly a pass is gone or something like that. So see this area here as a render preparation. Now comes the point, do I really want to have this file output every time I do a scene? No. And here comes the next cool feature inside of Blender. In Blender you can reuse all your stuff. For this, you have to understand that the blend file, if you save it out, so this blend project file is in reality like a database. And I have prepared in my system, I now leave that here for a moment, a special file. So if I go here into my production files, I go here to my Blender node group folder, you see it's under my Blender projects. Here's a whole bunch of files which I only use for referencing. And here's one of them which is named Compositor nodes. This is a blend file. I open that for you. The only thing I'm interested here, you see there are two cubes, nothing here which is interesting for me. The only thing which I am bothering is here Compositor. You see that I have here now two nodes, and these two nodes are groups, so named node groups. I make a copy of one of them, Shift D, and I bring it over here. And if you have a group inside of that, you can go into the group by pressing the Tab key. Now I'm inside of the group. And what you have now inside of this group is I have here a file output node. And you see I have pre-configured it. You see I have here a standard file name. I configured it here to float full. I have here a full list of all the passes which are generated inside of a Blender rendering, so everything. But I renamed some of them so that I like them a little bit more. So like I've said, for me it's important that I have a standard naming convention, and that's it. So I built this node once. You also can see you can add colors and so on. But this node is inside of the node group. So I go up here again with the Tab key or with this up. The reason why this here lives in a node group, by the way, if you want to know how a node group is made, let's add a node here only to demonstrate that. I have RGB, this is an RGB node, and you now want to pack it into a node group. You have to select all the things you want to have in your node group. Control G, now you are inside of a group. Yeah, and now you can go out. Now it's green. So you see, that's the way I've packed it into a group. The group later is not important, so you don't need to bother about these inputs here. But the reason why I packed them as a group is that I only can reference groups. So make groups out of them. And I have this standard EXR. We looked into that. The only thing I have in here is this file node, which is pre-configured for all my standard layers which Cycles generates here. And the other node which you find here is named Crypto EXR. I go into that, and you see it's another file node which I use for Cryptomat. There's one little gotcha inside of the way Cycles renders Cryptomats. Normally you get per Cryptomat, so for example if you take object here, you get 4 layers. So you get a layer which is named, for example, Crypto Object, and then you have the 0, the 1, and the 2. Funny enough, if you directly save out your OpenEXR from Blender, it only generates these 3. So many Cryptomat plugins are a little bit confused that this first layer is missing. What I've done here is I added this layer here also to the system. You see, it's all about naming, yeah? So I have asset 00, 01, and 02. Okay, and these two groups we have here. Now we want to see what's happening. So I saved that out here. They are placed inside of the compositing, so they are saved with that. You can set here a fake user if you like to make sure that they are never deleted, but yeah. Let's go back to our tutorial. What I now do is I need now these output nodes. So what I do is I go here to File, Append, and now I can show this file where these nodes are living. So I go to Blender node groups, and where it is, Compositor nodes. And instead of loading the whole blend file, look at that. If you go to Append or Link, you can click on a blend file, and if you make now a double click, you dive into the blend file here, and here are all the saved elements of your Blender scene. And here is the section for the node trees, and if you go here, you see there are 3 node groups here. One is the standard EXR and one is the Cryptomat. And I want to have, for example, both of them. So I select both of them, say Append, and now where are they? People expect that they are now here. No, you only added them to your blend file. To now place them, you go into your Add menu, or Shift A, or here, Add, go to Group, and now you see we have these 2 groups in our memory. I take now standard EXR, and this is the group we saw before, and I'm not interested in the group because the naming doesn't fit, so I select the group, right mouse button, click and say Ungroup. And now I only have my file output node. And you see all my names are there. Same thing. Let's do the same thing for Cryptomat. Here we go. I go here and ungroup it. And now I have these 2 outputs. And now the job is that I make the right connections. And now comes the nice point. Like I've said, all these here are available slots which I can deliver to the EXR. But if you don't connect one of these slots, they are not exported. So you don't need to add everything. You don't get black layers. It's really only for convenience here. And I have in my production also a script which helps me to connecting these. But I promised you I don't script in this tutorial. So what I do now here is I check here if the name is okay, render underscore AOV version 1. And for animation, I have here the pound signs. It's okay. I think that's nice. And now I start hooking this stuff up. You see, here normally we get also an alpha. I have an additional alpha here. Sometimes for me it's useful to do that. You don't need that. So I don't connect this here, but depth is something here. I use mist pass and so on. And now I think through the magic of retiming, we can do that now a little bit faster. So I hook everything up. I don't need the index here. Control right mouse button click to have this scissor. If I now see that something here is missing, what I can do is I can now go here into the settings. You see I haven't got environment here, so I add that here to my list so that I also can use that here. Really easy. And that's it. Yeah, for Cryptomat, you can do your own node here with more inputs. In my case, I really often have it as a second node here. So I take the image here to RGBA, so to see something. And now comes the thing with the 4 layers instead of 3. If you take a look here, you see, like I've said, crypto 00, 01, 02, but not the crypto object without the numbers. And what I do in my practice is I take here this image and take it as the first layer, and it works fine. So I hook this up here for all 3, and then I go through them and hook them also up. Okay, I hope I have made this now correctly. Like I've said, really often a script will do that for me, but I want to demonstrate it by hand. And what I now do is I go now here into my rendering process, and I increase now back here my render sample so that's a little bit nicer. Okay, I don't do denoising because I want to show you a little bit of that in a moment. I make sure that because I have volumes here, the light path, yeah, we have volumes here. I think everything is fine. Now let's render. And after the render is done, this tick here is set. These 2 nodes will now save our EXRs. See you in a moment. We can see here the render result while it's produced. Okay, let's switch over to our NUKE. Get rid of that here and read in again. So now you see here are our two EXRs. I load them both. And now you see it's much nicer. Now we have a nice image here. Let's start with the AOVs here. I hooked it up. And now you see directly inside your viewport an image. Why? Because now we have RGBA. Here's the alpha. And here are now the passes which we generated. I have here also an extra UV so that I can use that here later. And yeah, that's the setup I do here. You see, now you don't have distracting view layer names or something like that. If you have more than one view layer which you render, you can now have a second render layer node here. So it's here in the stack. So input, render layers. In this, you now select here which view layer you want to have here. Then you have the outputs and take one of these nodes again, change the name here so that it's clear that you have another view layer. So I would go here, say standard EXR, unpack this thing, and then you make it a second EXR for the second render layer, and so on. So you see, this system works for me here really fine. And if we now also want to check here the cryptomats, you see I have a beauty pass here on top, and here are now the cryptos. And so we can now take a cryptomat node here, and you see it looks good. You see everything here. Here's asset, here's material, here's object. And now we also can directly work from here to generate our masks here. Let's go back to Blender to finish now this lesson. One thing which is also sometimes really useful. By intention, I lowered here my sampling a lot to have it faster here for this tutorial. But sometimes we also have the problem that we want to manipulate a pass here. Let's do an example with that. I take this node and hide it so that we collapse it. And if we take now a look here into these layers, let's take here the viewer node so that we can see what we are picking here with our viewer. Let's do something like the shadow here. So I Control-Shift-click here at the part of the shadow, and now you see that's the shadow pass. And you see, for example, a big problem here. You see, okay, the shadow pass is too noisy. Everything else is absolutely okay, but the shadow pass will be a problem. What you can do is you can also use now here the compositing environment like it is wanted to be used inside of Blender. For example, you say, okay, inside of the compositor of Blender, we have the Intel AI denoiser, and I generated here in the view layers denoising data. So for the AI denoiser, and I can directly use now this denoising data here inside of the compositor before I save it out here into the pass. So that's the big advantage now here. So I take from the filters, Shift A for the nodes, filters a denoiser node. Here it is, denoiser, that's the Intel denoiser. He wants to have a little bit more information so that it can work nice. So here's the denoising normal. We haven't outputted it to NUKE because we don't have it there. Then we go here to the albedo, which is the denoising albedo. And this image here is normally the plate which you want to denoise. And in our case, we don't want to denoise the beauty here because we want to do something else. So we take here the shadow pass, which we want to denoise, and plug it in here. And if you now look with Control-Shift-click here into the denoising result, you now see this is the denoised shadow pass. Let's select the node here and press M like mute. You see before and M again here after. Now the shadow pass is nice. And so now I go in here and say, instead of using the original shadow pass, which we had here, I'll plug in here now the denoised version of that. And that's the way I work normally also with other things. So I can manipulate passes before they are saved out. Like I've said, if you have watched my other tutorial series about the compositor here, you will see many nodes and how also this workflow with the low resolution works. So this is all render preparation and preparation for compositing. If you are then finished, you are happy with your results, you know exactly what's going out, then I normally go in here, say I want to do this with 100%, and then I also can save out directly here animation. And this here will be generated, but it's not important for me, this name. Yeah, it's only helping. I'm only interested in these outputs here. So I unhide this here again. And that's it. Let's render again this still image, not the animation. This will now take a while, so I go here back to the render result. You now see we have now the full resolution. Maybe you have now more samples. And yeah, now you have your render pipeline for the whole project. I hope these ideas were useful for you. Like I've said, we can have it a little bit more automated, but I think that's good without any coding. Learn how to set up your output nodes here, save them as node groups in separate files, append them directly and use them as often as you like. If you have more questions, please ask. You can reach me through the comments under this video or also per email if you like. If you want to support this channel, please give me a like. If you want to have this file here only for playing purposes, you find them free on Gumroad. I put the link in the description and also on my Patreon. I hope this was fun for you. Have a great time and have fun in Blender. Your Helge Maus.